Right, guys, how are we feeling about kicking off then? I see we lost half the audience, but the important people are still here. Okay, so we've decided to change the agenda because there was less than no interest in talking about trust frameworks for 2 hours. So we're going on to use cases and demos instead, which I think should bring this a bit more to life. Okay? So we're missing that bit of the agenda and we're going straight onto this bit. All right, so what I'll do is I'll just finish off some of the slides from this morning just to kind of anchor ourselves back in the conversation again, and then we'll do some demo stuff. So this morning we finished off on this myth-busting stuff, right? What self-sovereign identity doesn't do. So the next question then is, what does it mean for people? So this is trying to bring it away from the technology into the actual implications for us. And one of the first ones is no more usernames and passwords. Okay, that in itself is pretty huge. Second one, no more registration forms. So you won't have to go online and fill in any forms anymore. Okay, whether it's your advanced passenger data or it's your delivery address or anything. What will happen is as you'll see in a minute, you'll click a button, scan a QR code, and you'll send the data direct from your phone. No more spam and phishing. This is a bit of a biggie, this one. Because there's nobody in between the connection that you have, nobody can impersonate the other end. So if it's me and my bank, if a communication comes to me from my bank, it will be signed by them using their private keys, and it will be sent down the pairwise DID connection that we have. So it means that at the moment it's very easy to impersonate a bank. You just send an email that says it comes from the bank, even though it doesn't. In this new world, in order to impersonate a bank, you need the bank's private keys. Hopefully banks are pretty good at keeping their private keys private. But it means there's nobody can insert themselves into this peer-to-peer connection. And that's how spam and phishing works, by people pretending to be somebody else. Also secure private communication. So every connection you have will be secure and private. And you could exchange pictures of your cat or credentials or MRI scans or whatever you want to do there. And nobody in the middle watching what you do. So that's a whole bunch of benefits for people. But basically it boils down to the internet becoming much easier and more secure to use. For organizations, there's always been this trade-off, right, between security and friction. You either have low security and low friction, or you have high security and high friction. You've never been able to have low friction with really high security. But the thing is that you can do that now. Okay? So you'll be able to verify customer data instantly for onboarding a new customer. That fast onboarding, really good customer experience. One click on board to get a bank account. Regulatory compliance becomes easier because you no longer have the data coming from some centralized attribute exchange. The data is coming from the person directly with their consent. And that has all sorts of benefits from a GDPR perspective. And you don't have to store the data you get. So in banking, obviously, there's regulations that mean you do, but in retail, I could take your delivery address, your name, your payment card details, and payment cards can be credentialized as well. Okay? So you can verify that a payment card is authentic and it belongs to the person with the name and address, and that was issued by a bank. So payment card fraud can go away as well. But what you can do is, as a retailer, you could receive the information, delivery address, execute the transaction, and delete all that data again, apart from the DID of that person. Because it's so easy to go and get the data again if you need it. And organizations can have a secure relationship with every customer that's unique. They're not relying on WhatsApp or Facebook or Google or anybody else. They have a secure peer-to-peer relationship that's unique with every single customer. And then you get this, what we call interoperability across silos. So many organizations, large ones, have many different silos, data silos that don't talk to each other. Either there's a technical reason they don't talk to each other, or there's a regulatory reason they don't talk to each other. It can be very expensive to try and make them talk to each other. So these silos are a big problem, because I can be a customer with a current account at a bank, and I can then want to get a mortgage, but that's a different piece of the bank, and I've got to prove who I am again to the mortgage people, even though I'm already a customer. Much simpler is if the bank gives me a credential, and I can then carry that credential to the other part, the other silo, and say, look, I'm a customer over here, so please let me in over here. So the customer becomes the courier of the data across all your internal silos. We call it cross-silo interoperability. So that's some benefits for organizations, but there's plenty more, and I'm sure you can think of a bunch of them. But the main thing for organizations is lower friction and higher security at the same time, and that's not really been possible before. So I'm just going to give you some examples of some of the projects we're working on. So Barclay Card, part of the Barclays group, they're a merchant acquirer, so they have thousands and thousands of retailers they do payment processing and card acceptance for. And what they wanted to do is enable those merchants to onboard customers with one click. And that entailed issuing two credentials. The first credential was the customer's identity information, name, address, date of birth, what account type you've had, how long you've had it, that kind of thing. And the second credential contained payment card details, suitably tokenized. So when the customer went to a retailer, they would go find the things they wanted, go to checkout, and they'd be presented with a whole long form with all the data, everything that needed to be filled in, or a QR code. If they scan the QR code, their phone goes ping, and it would say, Tesco want to see name, address, are you over 18? Yes, there we go, and it's done. No form filling at all. So that was really interesting, and not only were they presenting the identity information, the delivery address and the over 18 check, it was also presenting the verified payment card details as well. So the payment could happen, and that was linked through into their payment gateway to just use the normal Visa rails. So that was quite cool. This one is trusted identity and single sign-on for doctors. I talked about that earlier this morning. This is a project with the National Health Service in the UK. True are an organisation founded by doctors to solve the problem of knowing a doctor as a doctor. And what they can do basically is credentialize the doctor. The doctor has a whole bunch of credentials. When they need to go to a hospital for a new role, and they change roles every 6 months. So doctors are very mobile in the UK. That doctor can be onboarded in 5 seconds remotely by doing a credential verification. Once the doctor's onboarded, the hospital then gives them another credential that says, right, you're now working at this hospital for 6 months. And the doctor can then use that credential to sign into all the hospital systems. So this is a project, the National Health Service is the customer. We're partnered with Microsoft, who've got Active Directory at the back end. And they've got real doctors doing this at the moment, and they're looking at expanding it next year. Here's another one, CU Ledger. They're a consortium of credit unions in the US, and they're trying to solve a very simple problem, which is authentication. So secure customer authentication when the customer calls in or walks in or logs in. And the way they're doing this is with credential-based auth. So the credit union gives the customer a credential, says you're a customer of the credit union. It goes in the wallet app or in the credit union app with the wallet SDK built in. And the customer is then able to, if they call in to the call center then pings the phone and says, please prove you're a customer. That's a credential brief request. The customer says, there you go, sends back the proof, it's authenticated, and they're in. So they think they want to go from 80 seconds per authentication to 10 seconds per authentication. That in itself is a really big business benefit. Because then the customer has a credential that says they're a credit union customer with their name and their address as asserted by the credit union, and that's going to be useful in a much broader ecosystem as things evolve. The biggie, KYC checks for banks. This always comes up because the problem's so big and it's so expensive. So here we're working with a bunch of banks. So ATB is Canadian. The others are in the UK. The other four Monies, Curve, Cedars, and Be Social. They're fintech type firms, really mobile experience, all about fast onboarding, get your account quickly. The example here of onboarding time from 45 minutes to 45 seconds, that's the target for ATB in Canada. But the one in the UK is actually with the regulators as well. So the Financial Conduct Authority is involved in this one. There's also a major high street bank who have asked not to be named, but they're in as well. We're partnered with Deloitte and OnFeed. OnFeed are an identity verification firm. This is a sort of take a picture of your passport, do a selfie, they'll verify that, and then they issue a credential that you can use many, many times. So that's happening as well. Under the skin is Ebenim's Verity Credential Exchange platform. So that's our piece of this. So it's really interesting because we've got the regulator involved, all the questions about liability, GDPR, the whole sort of business process flow, risk management, they're all coming up as well. We've got real people getting real bank accounts using verifiable credentials in the UK. So this project is drawing to a close now. There's going to be a report coming out about it, which is, I think, going to be a really influential report to show basically that digital credentials can be used for onboarding bank accounts in a regulated environment, which is a fantastic finding. And we talked about verifiable organization network earlier on, so I won't bother going into that too much. But that's just a fraction of it, and that's just the Ebenim stuff. So we're one company in this ecosystem. There's plenty of others. So Uport, for example, they work, again, with DIDs and verifiable credentials using the Ethereum ledger. And there's actually a meeting taking place in Utah at the moment called the Connectathon. And the Connectathon is all about all the companies that have emerged working in this area, meeting together to get interoperability between all of their wallets and credential exchange protocols. So there's folks in there like Uport, the British Columbia guys are there, there's Street Cred, Matter, there's a whole bunch of new companies that are just emerging that are starting working in this space as well. So it's really, really interesting to see what's going on. There's also some biggies like IBM. They're going all in on this stuff. Microsoft, as was mentioned earlier, they're big on DIDs. They do want you to host everything on Azure, but then that's Microsoft, so that's fine. But everyone's got their own motivation. So our motivation at Ebenim is selling enterprises a credential exchange platform. So all those things that I mentioned right back at the start, you can have a single platform wherever you buy it. It's not going to matter. We hope you might buy ours, but you could buy one from IBM or buy one from Uport or wherever else. As long as they use DIDs and verifiable credentials, it's a bit like email servers using SMTP. So it's still quite early days. 2019 has been a year of people going from POCs, technical POCs, to pilots with real people. And 2020 is when that's going to emerge and expand and get larger. So you can have a single platform. If it does DIDs and credentials, you can do so much stuff with it. You can do staff ID, you can do customer ID, you can do customer onboarding, you can do sign-in, etc., 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 etc. So that's the end of this slot. I'm going to plug very quickly because I'm allowed because I've got the PC. So we've got something called the Early Access Plan. So we've got 50 odd organizations who are busy experimenting with Credential Exchange at the moment. So if you want to play with it, then we have a way that you can do that. That's some of them. And as you can see, they're all different market sectors. They're different projects they're doing, different use cases. But what's common to them all is they're all exchanging credentials with each other. Okay. Hi. We changed the agenda slightly. There was very little interest in talking about trust frameworks for 2 hours. But what people want to see, they want to see demonstrations. So that's what we're going to be doing. Okay. All right, so far, any questions on just that, finishing that one off? No? All good? Okay. Okay, so demo time. Let's just get rid of this. What does a credential look like? All right. Is this working on there? It is. Okay, so this is my phone, as you can see. What we've got on the screen here is my phone on the right-hand side, and on there we're going to start up connect.me. Okay. So I'll just kill that and start up again so you can see it. You can get this in the App Store now, and there is a tutorial to take you through as well. So you can, if you want to now, go to either the Play or the iOS App Store, connect.me, and install this, and you can run through and get some credentials right now if you want to do that. So here, I've got some I prepared earlier. So these, what you're seeing on screen is my phone here, and on the left-hand side, we've got 1, 2, 3, 4, 5 tabs. Okay, let's ignore these two for a minute. We've got 5 tabs, and each tab is a different simulated organization. Okay, so this one you see at the top right is the bank. This one is the driving license authority. This one is a retailer, and this one some government authority. We're going to figure out what that is shortly. Okay, so what you're looking at is an administrator interface for issuing and verifying credentials and setting up credential definitions and types. And on the right-hand side on my phone, I've already connected, oops, back to there. I've already got 2 connections. I've got a connection with the driving license people, and I've got a connection with the passport office. So the passport office here, as you can see, I have a connection with them, and if I tap on the top right, that's my DID and the passport office DID. So if you want to know what a DID looks like, it looks a bit like that. Okay? So if we look at the driving license authority, different DIDs. I hope you noted the first one and you're comparing, right? So this is our pairwise DIDs. Nobody's ever going to, no normal person will care about DIDs, by the way. It's like caring what your MAC address is on your laptop, right? I was at a conference and I said, you know, who knows what the MAC address is on their laptop? And this guy at the front said, I know mine. Seriously. So with the driving license people, you can see here that I've actually shared with them some information. So I've shared some passport details, okay, and this is what I've shared. And I've received a credential, which is a driving license credential. All right, so far? And the passport office, I've got a credential from them, which looks like this. Okay, so what I'm going to do is show you what a DID connection looks like and show you what a credential issuance looks like, an approving exercise. So we're going to go to the bank. Okay. So this interface, just to explain it, you've got connections, you've got issuing credentials, you've got requesting proofs, and you've got the configuration of creating credential definitions and proofs. So don't worry too much about that. I'm just going to show you how you make a connection. So what we're going to do is we're going to say add connection, and in actual fact this will be automated, you know, it'll be a website, and this will all be under the skin. Okay, so let's just do this. So this is the bank's internal reference for me, they create a QR code. Now, in reality, I'll hit the bank website, and it will say on it, scan a QR code. So they already do this. So on the phone, okay, you all are, look. I'm going to scan that QR code. And it says, hi there, the bank wants to connect with you. And I say, okay, connect. I want a biometric. Close this now. And that's done. So that's a DID exchange done. So what happened there was my phone created a new private DID, and it sent it to the bank. The bank created a new private DID and sent it to me. So we now have a unique DID-based connection between me and the bank. So it's really easy. That's it. Okay. All the stuff we talked about this morning that sounded really complicated, private keys and all this kind of thing, all you do is you scan a QR code. So there's my connection with my bank. And as you can see, this app starts to look a bit like an address book. It's like a turbocharged address book with loads of, you're going to accumulate more and more connections, just like you do with your normal address book, and you'll accumulate some credentials in there. So now the bank wants to know who I am. So we've exchanged the IDs, but the bank doesn't know who I am yet. So they're going to send me a proof request. Okay, the proof request is, please give me some data. So we go here, so we're going to say request data. And we've got some template proof requests. So let's do passport and driving license. Okay, this is what it's asking for. Passport last name, given name, driving license name, does that match? Passport date of birth, passport expiry, driving license date of birth, etc., etc. Okay, send proof request. So in reality, this will happen automatically, driven through some workflow on the website, and here it is on the phone. So you can see my app has already filled in the data from the credentials I've got. So I don't have, as a user, I don't have to do anything. The app has said, hey, what's your passport expiry date? And you can see the little icon here that relates to the passport office. This one has come from the driving license guys. So here, this is an example of two things. First of all, selective disclosure. So I'm only disclosing certain attributes from the credentials I have, not all of them. And I'm combining attributes from two different credentials into a single proof. So I'm going to send that. And you'll note that I have on my phone a record of everything that I've done. Okay, so this is my audit trail. And not only have I got a record of everything I've done, the bank has a record of everything I've done as well. Okay? And here we have the proof that's come in. It's really hard to see. Can you see that at all? It's really good on here. Yeah, that's not so good, isn't it? Let me describe what's on there for you. In fact, I wonder if I do this. Is that better? What you're seeing is the data. Yeah, there's my address. Yeah, that's all right, isn't it? Yeah, so you can see here's my address from the driving license authority, and here's the schema and the credential definition that belongs to the driving license authority, which has been used to get the keys to verify this data is good. Okay? So that's a proof. Okay, now the bank can now onboard me because it's able to verify that all that data is authentic. So as a user, all I've done is I've scanned a QR code, my phone goes ping and it says the bank would like to see this data. Simple as that. Now, the bank can now issue me a credential. So because they've given me a bank account, so they're now going to issue me a credential. What credential are they going to issue? Well, it's a bank account credential, amazingly. And what's going to be in it? So it's going to be first name, last name. So this is just data that they've just accumulated from me anyway. It's a current account. It's open today, 2019, 12. What is it today? 5th or something? I've got a credit rating. Okay, so I'm going to have a 99 credit rating. And then I send the offer of a credential. What does that look like on the phone? It looks like this. Okay, the bank account is offering you a credential. Do you want to accept it? I can not accept it. It's up to me. I'll accept it. Okay. And this is how you'll go and keep accumulating credentials like this. So here I have it. So I can see them in the relationship with my bank. I shared with them that information. And I've received from them this information. Good so far? It's pretty easy, right? So we have a couple of other enterprises. We've got a retailer here. So let me just connect to this retailer. Now, in reality, again, the retailer will just have a website and they'll have a QR code sitting on the front of that website. And you'll go to the website and you'll browse the QR code like this. And as soon as that connection is made, let's just do that. As soon as the connection is made, they'll then send a proof request out. Okay, but the way we're doing it here is just separating the steps out. Okay, so I've got a connection with my retailer now. I'm now going to request some data. So the retailer says they don't know who I am yet, but they want to check I'm over 18. Okay, they want to check that using a driving license. So here it is. All they want is the driving license date of birth. So this is just pulling one attribute out and sending it. Okay, simple as that. Now I now have that connection with that retailer, and that connection is persistent as long as I want it to exist. So yeah, question. Yeah. Do you want to turn your mic on?
When you just press send from your mobile phone, how the data will be passed through the network to the requester, let's say?
Yeah, how the data
passed? What will be moved actually?
So what's moved is
it the zero knowledge?
In this case, what's being moved is the actual you can't see it, can you? Is the actual data there? So
the actual data.
In this case, this is what they wanted, was my actual date of birth, okay? So that's what's been moved.
The actual data?
In this
case, the
network
itself? Or
yeah.
Channels?
So what's happened is that data has been encrypted by the app. By the app, and sent down that channel. So it's been encrypted using the public key of the retailer. So only the retailer can decrypt it.
Can be only decrypted through the
only by the retailer, yeah.
But through the network itself, the blockchain network.
No,
outside?
It's not. This is not. Okay, yeah, I see what you mean. This is not touching the ledger.
The ledger itself.
No, this is direct straight to the retailer. There's no record of any of the transactions you've seen. None of them have touched the ledger at all. Okay, there's no writing to the ledger here. All that's happening is when this proof is verified, this retailer, simulated retailer, is reading from the ledger the keys of the driving license authority. Yeah, so there's no record anywhere of this exchange of transaction other than between me and the retailer. So it's not touching the ledger, nor should it, because it's no one else's business. Yeah. So this is a private peer-to-peer transaction, edge to edge. Okay. So we've got two steps here. You've got the establishment of a connection, and then you're either creating and issuing a proof, or creating and issuing a credential, or requesting a proof. That's it. It's as simple as that. Okay. So we were talking earlier on about an example of people being agents, money agents. The gentleman had to go, didn't he? But
agent network, yes.
Yeah, an agent. Yeah. So people being able to accept sort of M-Pesa type stuff in Kenya, for example. Okay. So how could we create a credential for a money exchange agent? So let's pretend, so this fifth instance I've got here, this is a government authority. So let's maybe, who licenses money exchange agents? Do we know? Who is it who does that? So the use case you were talking about earlier on, yeah. Well, okay. Let's say just for the sake of it here, it's the government regulator, right? The government agent. Yeah, the government agent regulator. Okay. So what we're going to do, we're just going to change the name of this one here. So this is just a bit of config here. Let's call them the money agent regulator. Okay. So this is just so we can recognize what it is. So we're going to create a new type of credential that this money agent regulator can issue to people. Okay? And we do this like this. And here we are going to be writing to the ledger. Okay? So we're going to create a money agent credential. And the first thing we're going to do is we're going to create or set up the names of the attributes that go in this credential. Okay, so first attribute will be let's do this. Okay, so this is your like data dictionary. Okay, agent last name. Can you see this all right? Yeah, it's all right, isn't it? What else would a money agent have? Yeah. Maybe they'd have a serial number or a registration number. Okay, so we'll just keep it simple with five fields in it. So what this schema does is it enables anybody to understand a credential that has been issued. So that schema has just been written to the ledger. Okay, just then, it just happened. It's pretty quick. And a schema can be used by anybody. So it's like a template. So if we had university degrees, it might be that some organization decides what a university degree credential looks like, and they write the schema. And then what you do is for each institution that's going to issue a credential, they create their own instance of that schema with their own private keys in it. So here we're going to, this is going to be, and this is called a credential definition. So there's two steps. You create the schema, and then you create an institution-specific instance of it. So if there had already been a money agent schema, I could have just used it, right? So let's do this. Let's call it ITU money agent credential. 0 for that. So you see it's using the schema ID, and now what's happening is this is creating public-private key pairs for each individual field in each attribute, and it's creating the credential definition and writing that credential definition onto the Sovrin staging net. So we're using a test network called staging net. It's writing those onto the staging net, and it's done. Okay. So anyone who's worried about how long it takes to write things to ledgers, you can see that that's done already. But that's it. There's no more writing to the ledger will happen. Finished now. Okay. This institution can now issue 1 billion credentials without ever writing to the ledger. That's what makes this really scalable and powerful. Okay. So what this money agent regulator needs to do is they need to know that the person coming to them to get this credential is who they say they are. So we're going to create a proof request template that's going to request some data from this person. Okay? So let's just go back to here. So let's say they're going to want to request, so we're going to create a new template. Check money agent ID, we'll call it. And here we're going to put in the attributes we want to see. So we're going to want to see passport given names. What else got? Passport. Okay, it's going to want that. Okay, maybe we want a date of birth. Don't know why we would need it, but let's put one of those in anyway. Name, address, date of birth. Do we need an address? Yeah, we need an address, don't we? So the address would probably come from the driving license, which is called... Now at the moment you have to be quite precise because attribute name matching is done. Now this is going to evolve and you're going to have what's called rich credentials, where you will be able to specify a credential of this sort from this issuer with this DID, or a credential of this type with this level of assurance associated with it. Let's just see if we've got address here somewhere. Yeah. Okay. So I was just cheating by checking the, make sure I got the syntax correct. Okay, so we've now, the money agent here has now got a way of requesting data and then sending a credential. So what we're going to do, here's a scenario. Andy wants to be a money agent at the Kenya M-Pesa, whatever it is, infrastructure. So I go along to the money agent regulator and I say, hey, I want to be a money agent. Well, I do this, most likely I do it remotely. Okay, so I go onto the money agent website and they're showing a QR code. So what do? I scan the QR code and I connect. So this is all like feeling a bit like deja vu because it's the same protocol being used. Okay, I'm now connected to the money agent regulator. Okay, there's the DIDs that are used. And I now want to find out who is this person that's just come along. Let's ask them for these details. My phone pops up, says, money agent regulator wants to see your last name, your address, your date of birth, and your given name. I do send. And it takes a few seconds, it will come up on here. There we go, received. Okay, and I know it's really hard to see, so let's do this again. So basically the money agent now has this identity information that's come from my passport and my driving license. Okay, so this is pretty simple. It's not hard to do this. Okay, I've got a nice user interface that lets me do the admin functions to create these credentials and proofs and so on. So the money agent regulator now knows who I am, and now they can issue me a credential. So they can now say, okay, we've received that. We're now going to issue you a credential that says you're an authorized money agent. Okay, and here they would have taken the data in. They can now spit it back out again and send it to me as a credential. So agent registration date 9/12/05, agent location Geneva, Switzerland, for the Swiss bank account agents. And some number. Okay. That's it. I accept the credential and I now have it. So now I can prove to anyone anywhere that I'm an accredited money agent. And it's really as simple as this. This shouldn't look complicated. In fact, when you put a web front end on top of this kind of interface you're seeing on the left, and make it look like so it's a retailer or it's a bank or whatever else it may be, it's really, really quick and really easy. But I wanted to show you what's involved in creating credential definitions, to show you that you can create a credential definition about anything as quickly as you want, whenever you want. The credential definition can have any data in it. So there's no sort of restriction. There's no central authority saying you can only issue credentials about money agents. You can issue credentials about anything. It's up to the recipient as to whether they want to trust the issuer of the credential. Okay, so far? Yep. I mean, that's credential exchange and DIDs. It's literally as simple as that. I might have a video I could show you actually of the Barclaycard project, but I think the resolution on the projector isn't going to work very well. Just give us a minute, I'll see if I can find it. Any questions so far, though? No? Is this helping just to understand what some of the use cases could be? Yeah. Question?
I just want to find out. So let's say a commercial bank would like to implement something like this. So how would this look? So I would go onto their website, whatever, and then the login page. What do I find on the login page?
Right. So if let's say you're an existing customer of the bank, right? And you've already got a username and a password and 2FA to log in and all that kind of stuff. And you've probably already got a bank app as well. Okay. Then what will happen is when you're logged in, it will say, "Oh, would you like?" They probably won't call it a digital credential, right? They'll probably call it something else. But would you like a digital credential that you can use to prove your name, address, date of birth anywhere? And you say yes, and they'll ping the credential down to the wallet. It'd be as simple as that. When you then go back to log in, you'll be given the option to put your username, password in 2FA, or there'll be a QR code. You scan the QR code, and the proof request comes up on your phone, and you're in. Okay. So that's how it'll look. And the idea is that it's going to look really simple. The app on your phone becomes essentially a sort of turbocharged address book. It's an address book of connections that are based on DIDs. So just give me a second. I'm just going to see if I can find this video and show it to you, because it'll give you an idea what the user experience would look like. Let's see if I've got it here somewhere. Okay. I'll just move this. All right, let's go back to the beginning. I hope the resolution is going to work on this, so let's just have a look. So this is a travel agent demo. Yeah, you can see it. Okay. So what's happening here is you've got the person's phone on the right-hand side. This is an earlier version of ConnectMe App. The person goes to travel agency, and they're selecting their flight, their holiday, and all the usual stuff. Okay. Now the person's they've already got some credentials from their bank. So they select this, they're going to have that car, and all the usual stuff. Really exciting bits. And then you get to the checkout page where you have the big field on the left-hand side, wanting all of your details, your passport information, payment card information, and so on and so on. Or you've got the ability code software. Basically, what it is now is that triggers a proof request. So it's easier as information, it's the same information that's wanted on the form, but you don't have to put anything in. This is a proof request, just like what you just seen. Press send, and that comes back on here in a second, and it says, so it's actually that proof request included the card details as well. There was a payment card details, accept it, and done. So that's the checkout, and payment done. Okay. Then, travel agent issues a new credential, which is the ticket. Receipt is the car booking reference. And if the car was a credit card, you could scan the car when you arrive and boost the car you're about to enter. Okay, so it's not meant to look overwhelming, it's meant to look really, really simple. I might have another example I could find in a second as well, if you're happy to bear with me for a minute. Let's see what else we've got. And then maybe, Maybe Kim, you've got a few as well, right? Yeah. So let me just see if I've got another video here. Just one sec. Some of this stuff I'm not allowed to show you, so I'm going to try and find the bits I can show you. Which other ones? Oh, the other, yeah, no, you can't do that. Let's just have a look. Just bear with a second. I just want to check it's the one I think it's. Okay, so this is this my CUID thing. It's just, this is 12 minutes, so I'm just going to skip along a bit. So there's a voiceover going on at the same time, but essentially what you're seeing on the right-hand side is a credit union call center interface, and on the left-hand side is a customer's Credential wallet. Okay. And let's just go forward a bit. Okay. So first of all, what happens, this is the setup where they start with a new wallet, they do the connection to the credit union, and they're going to then issue the credential. Okay. In fact, I'm going to skip along a bit further. So you've seen this stuff already. Okay, so I'm just going to pause there. So just imagine the setup's just done, so we skip past it. But the next step is the customer calls back into the call center, and the call center wants to authenticate them. So they could ask all the questions about the stuff you can see here, you know, what was your first car and what's your favorite color and all the stuff that you immediately forget. They could do that, and it takes them over a minute to do that. But instead of doing that, they're going to use authenticate using my CUID. And what that essentially does is it sends a proof request down to the customer's phone saying, please prove you've got a credit union credential that we gave you before. So that comes up, they say send, it comes back on the other side, and you get a big green tick. That's it, done. Okay, so that's taking something that would previously take over a minute and taking it down to less than 10 seconds. So there's a big improvement for the credit union there in terms of their call center handling times, and that's their business model there. All right so far? Cool. Any questions? Anyone want to try catch me out with some weird credential they want to see? Something. Yeah.
Would there be an instance where when you are getting the request, you find that some information is wrong?
Okay, so give me a scenario there. So when you're the bank, you mean, or when you're the person?
No. So for example, you've bought your car, I mean your holiday accommodation.
Yeah.
And then when it requests you for that confirmation to say, is this you? Use Sovrin to confirm your details.
Yeah.
You go through, you get the request on your phone, and you find that your surname is wrong.
Ah, okay. So you got a credential from someone else that's incorrect.
Yeah.
Okay, yeah. So that's a really good question, actually. So that could happen now as well. So you could get a passport with the wrong name on it. Maybe it's not such a good example of the passport. That should be good, right? You could get a student ID with the wrong name on it. Or you could have a utility bill with the wrong name on it. So what do you do in that situation? You ring them up and you say you've got the wrong name, and they do, oh yes, I have. And then what they do, they give you they send out a new student ID or utility bill. In this situation, you've got a persistent connection with the organization. Now, across that connection, you can do messaging. Okay, so you can do secure peer-to-peer messaging through DID connections, which itself is mind-blowing because that's like secure peer-to-peer messaging for everyone in the world with no WhatsApp in the middle. Right? But I could send a message that says you got my surname wrong, and what they would do is revoke that initial credential and send you a new one. It's kind of as simple as that. Okay, so what you're seeing here is just the Evenim's implementation of the open standards. There are others out there as well. So Uport have an app as well, which actually I've got on here somewhere. Okay, so here's the Uport app, and amazingly it looks fairly similar, right? There's only so many ways you can do this stuff, but there's going to be some really interesting innovation around what this stuff looks like. But here's a credential for a job, and I've got a museum membership one. And again, you can do this. Uport have something called Uportlandia, which is a demo, much like we have with try.connect.me, and you can go and try this out. So I'll just show you this quickly. So if you want to do this yourselves, if you go to this website, try.connect.me, that will get you the Evenim app. Uport have one called Uportlandia, I think it is. And you can start a tutorial, and what the tutorial does is, actually, I'll show you this. Yeah, let's do this. The version of ConnectMe I'm running there, that's connected to the staging net, but this is all on the live production network. So what I'm going to do, I'm just going to delete this app, the ConnectMe app, and I'm going to install it again. And the reason I'm doing this is because I need to switch onto the production network. And I'll show you this working on the live network. Here we go. Install. Open. So this is the setup that you go through to start. You accept some T's and C's, you start fresh, and if you're going to be playing about with this stuff, you'll see this switch at the bottom called Use Staging Net. Okay, so that's going to be off. The previous example, I was using the staging network, so use biometrics, do the print, also have one of those in case the fingerprint fails. Okay, we now have a clean install. So now we've got on the screen, we've got Faber College, and I'm at Faber College, and they're going to give me a QR code. I'll allow that. Okay. Faber College wants to connect with me. So, and this, it's just credentials and proofs every single time. Right, so the user interface is going to look the same every time. So once you've seen this a few times, it's going to get pretty boring probably. I didn't test this beforehand, so I'm assuming it's all going to work all right. I'll probably get demo-itis at this point. Okay, so I'm now connected to Faber College. So I now have a nice pairwise DID-based connection with them. And you see there's some... let's just do continue. Well, all the person is going to see is a QR code, basically. Okay, so Faber College, I've graduated. I'm called Alice now, by the way. And they're going to now send me my degree certificate. Okay, a degree certificate is just a credential. Here it comes. I'll accept that. It's done. Okay. So exactly the same process as we saw before, but on the left-hand side, we've now got a web front end rather than the admin interface you were seeing previously. So I've now got my college degree, and I'm now going to go and apply for a job. So here I am at Acme Corporation, and there's a job, a junior software engineer, $90,000. It's not bad. And I'm going to apply. So there's no forms to fill in, as per usual. So they give me a QR code to scan. It says scan this, and I connect. Biometric check, and I'm connected. That's the DID exchange done. And there's workflow under here to automatically move on to the next step. There we go. Thank you, you're now connected. They know who I am. and they want me to share some information. Here comes the proof request. They want my degree, my university degree information. There it goes.
Sorry, one more time. I actually wanted you to pause over there. Are we able to prevent some items from being sent through?
Ah, okay.
So, for example, student college name. I don't want my major to go through. So I just send.
Yeah. So the answer to that is theoretically yes. At the moment, in the ConnectMe app as it is, no. You can, if there's information that's missing, you can self-attest it. Okay, so it will come up and say, here's information we've got already, but you're missing this, so you type it in. It's then up to the relying party to determine if they want to accept it. When you get to rich credentials, you might have several attributes that have your surname in. Sorry, several credentials with your surname in. So one from the passport office, one from the driving license, and so on. So you might be able to select which one of those you want to share. Sort of swipe it and say, well, don't share this one, share that one. Okay? So not yet, but that's the idea of the rich credential schema. As you can see here with Acme Corporation, they've got all my data, say continue, and so I'm kind of I've applied, I start on Monday, and they're now going to send me an employment credential back down the line, and that's a credential from them. Excuse me. And the idea of this really is just to show you what the web front end is looking like. What's the actual experience going to be for the person? And as you can see, it's really quite simple. It's still a change to what's done at the moment, but it's a lot easier than typing in a whole bunch of information. Because when you type information in, you could be typing anything, right? Anybody could be typing anything. There's no verification, there's no authenticity to that information at all. So here we go, I've been hired, press next to continue. Happy days. I'm now going to go and get a car. So I'm at Thrift Bank now, and I've got to fill in this big loan form, which is pretty boring. Or instead of doing that, I can just scan this QR code. Oh, QR code format is invalid. Oh, there we go. Come on. Okay, so like one-click loan application for a car loan. So I hope you're getting the picture. Like the user interface is the same sort of thing all the time. It's a credential, or it's a proof, it's a connection, and away you go. So we put this together just so you could see the sequence and the flow and the sort of stuff you can build. So this is built on top of our Verity platform under the skin that does the credential exchange stuff. Now there's something else in here actually. In this version of the app that you get from the App Store, I can actually get all these credentials I'll be doing here, they're all just demo ones, but I can actually get a real one. So you see at the bottom there, it says, get your ID verified by OnFeed. And this is what we're using with the UK Financial Conduct Authority and the banks to do onboarding of real people. So here is, I'm going to do this for real now. Don't take pictures of my passport, please. Okay, so what we've done is we've built in the OnFeed authentication SDK into ConnectMe. Right, so what do? Is I scan my passport. Okay, passport is readable. Okay, I now have to do a selfie. Okay, so that information now goes off to OnFeed. So you'll see here, I've got a pairwise DID connection with OnFeed already. Like that's all happened in the background. Okay, so that's gone to OnFeed, and they'll do their checks, and in a few minutes I'll get a credential, an actual real credential, which is essentially digitized my passport into a credential, sent it to me, and that is good enough to open a bank account. And I can use that rather than at the moment you would have to, if you wanted 2 bank accounts, you'd have to do that twice. Here, I can use that credential, and I can use it again and again as often as I want to.
So all my data was pushed, all my credentials.
Yeah.
That issue not to my point.
Yes, correct. Yeah. So in this case, they've taken my passport information. They do their own processing on that, and they check it using whichever way they do it. and then they push the credential down to there, to the wallet. Yeah, OnFeed have already got a public key on the network, so it's not a public. There's not a different public key per credential. Okay, there's a public key for their credential definition that they write once. Okay, so to issue a new credential, they've already got their DID and their credential definition on the ledger, so they just push the credential to me. So they don't need to write any more to the ledger. Okay.
I wanted to add something about your question about I think you said, can you retract your last name, for example, or your how do you say, your major, right? You want to show maybe you graduated, but not your major. So there's several ways that, like you said, right now the usability story is not there, but there's several ways that are being discussed. So one is, for example, in the academic credentials project I'm involved in, because the sort of, I guess I would say, maybe the cryptographically fun approaches aren't quite there yet, right? So we sort of cheat and do things like issue different levels of granularity of credentials. So one practice that people are sort of working towards is, if you issue very fine grain or very, how do you say, atomic credentials or attribute by attribute credentials, then that person can use their wallet to sort of reform them as they want. So there is a concern that issuers have that, they want you to present credentials that are accurate, right? They don't want you to be able to remix that material and say you graduated top of your class or something. So there's still a bit of work being done there about, the recipient's interest in being able to have flexibility over what they show, but then also the issuer's interest in making sure it's representative and can't mislead people. But there are another way. Again, the usability story isn't there, but there's a signature suite on top of verifiable credentials, so you don't have to use it. It's an object called the redaction signature suite, and so effectively, a credential would have a whole bunch of hashes in it, and then you get to reveal exactly the fields that you want to, and they can make sure, yeah, it matches, and they can, they can check. You could reveal everything but your major, and they can still verify, yes, those individual elements were true, and yes, the whole credential was valid, but they didn't get to know your major. And then I'm sure that you guys have some even better zero knowledge proof kinds of things in the works. Yeah,
this selective disclosure, being able to pull one attribute from a bigger credential with many attributes, is really important, because you don't want to share more than you have to for a transaction.
Yeah.
And being able to do that is really good. So here you've been seeing me share one attribute from this credential and one from that one, and so on. So it's part of the credential exchange protocol. The OnFeed credential came in, by the way, so that's there. So this is a real credential issued by a real issuer from a real passport. That's good for getting a bank account. So there we go.
Yeah, I can share.
Do you want to plug in?
Yes, please.
What have you got?
I have.
Okay, I think we'll need to swap positions. Then.
Okay. So, since we have the extra time, I asked someone who works for Uport that's part of Consensus, and Sophie is with us, so she'll be able to correct me where I'm very wrong. But there was a good demo shown that Uport was involved in. Check.
Let's just get this anyway.
Oh, maybe I should just put it here. Is not my, oh, that is my background.
It's probably be on a separate screen, so I'll try and get up or down or something.
Yeah. Let's see. So there. I was looking for monitor and it wasn't there. Okay. So this is a prototype project again that Uport is another big player in consensus generally in decentralized identity, and so they have they also have, as Andrew was mentioning, some really good some of the best UI demos. Like if you want to sort of experiment with what it would look like in practice, Uport and Sovrin's demos are I would say the best to start with. And so they worked with, I'm going to call them GLIFE, not knowing if this is the right pronunciation. Okay, Global Legal Entity Identifier Foundation. And they issue corporate identity verifications. They're called Legal Identity Identifiers, or LEIs. And so these are 20-digit identifiers that are unique. And the idea is to help quickly answer the question of who is who, and this sounds weird, who owns him? I don't know about that. I don't think they mean.
It's for which legal entities are owned by which other legal entities.
Okay, yeah. Got it. So entities, okay. Okay, perfect. So, yeah, it improves transparency, reduces costs, all of this. But then, so one of the things, so that's GLIFE, but where they've paired with Uport is the idea of, okay, so you have a legal identity identifier, but then you have people that are working on top of this company, right? So how do you set up this, I don't know the right term in this context, but, chain of custody or the, how do you say, basically the extensions of capabilities, saying like the company allowed this person to do this action, file paperwork on behalf of this legal entity. So this image is kind of small. I apologize. That was the best I could get it, but we'll zoom in on separate sections. But the high-level flow is this. So GLIFE sets up local operating units. If you see this sort of flow. So yeah, we'll look into the credentials after that. But so then these local operating units can assign LEIs. So that's the thing that actually companies get to establish their legal entity. Then the LEIs can assign roles to their company employees, and that enables the company employees to take actions on behalf of the company, like filing paperwork. So then the employee down here might file documents, but then a regulator can verify this whole chain to see, yes, this person signed this documentation with a valid key, and they have the credential that authorizes them to do that, so they can trace it through the local operating unit, et cetera. So let's zoom in a bit because that's very zoomed out. So this is the, still feel like that's probably kind of small, but the LOU accreditation, so GLIFE is saying these local operating units are able to issue LEIs, so GLIFE will issue a verifiable credential saying this local operating unit can do this. Then this local operating unit can issue LEIs to individual companies upon the usual vetting process. Then the company itself could issue roles to their own employees or people authorized. So this is up to the company to basically decide who gets to do that. But so these credentials would express something like what role, and maybe map some capabilities to it. We'll see a demo of that in just a second, which Oliver from Uport provided me. Okay, so the usage part, the employees can sign and submit documents with their Uport mobile app. The mobile app lets them have a nice experience around, scanning to submit their signature. And then the regulators can view and verify the signatures and, like I said, walk that whole chain of permissions. So similarly, the regulator would have a nice interface where they say verify, and behind the scenes it's verifying this chain of credentials and making sure the officer has permissions as according to those verifiable credentials that they can share. So let's look at a demo, and also please, Anne-Sophie, if I'm butchering anything or if you have anything to add, I'd be interested to hear it as well. So let's go back to, sorry, I started in the middle. Okay, let me pause for a second. So what this is showing.
It's not on the screen. You need to.
Oh. Oops. Okay. Okay, so it's going to go fast, so let me pause right here. Okay, so this is the part where I'm some organization, I have an LEI, and I want to issue credentials to valid persons in my organization to say they can do certain actions. So this is what a UI could look like, and I'm going to pause it right away. Because this part is interesting. It ties to what Andy was just saying. So in this case, note that they're going to be filling out a dialog box of the employee's name, acting role. Note that they're also filling out permissions. So if this person already had their credentials represented in some verifiable credential form, that could be part of a separate automated ceremony. This is just showing what it might be like to, start using these at some point in the process. So this is saying, an officer of the company or, someone with permission is entering this. So this is, you sort of already have those structures within a company of a person who is trusted to do this. So that's why the manual entry is there, though. So they're entering this information about this person in the company who's going to be the CEO, and they will be allowed to sign regulatory filings and submit them. So this LEI, this is the LEI that they can operate on behalf of. Let's see. Okay, so what happens then is that person, the CEO, then gets an email with this QR code that they can scan into their Uport wallet. Let me make sure I'm not moving too fast. Okay. Right, and so here, actually let me back up a second. Okay, so here you see some things like, okay, so you have the issuing did, and I thought I saw the person's did, but this is the credential then that the CEO gets. So he has this, can carry it around, can use it to, he can do two things with it. He can use it as a credential to, authenticate with or show proof of doing something, but at the same time, he can use the Uport app to, with his credentials, sign documents that they might submit. So that's how the Uport app kind of combines a lot of these functionalities to make it easier. I think I'm near the close of the demo. Let's see. Okay, let me come back. So I think that was the highlight of that demo. Also showing these sort of chains of verifiable credentials and permissions that get associated with. So one thing I should add there actually is that, okay, the CEO, he got this credential, and this credential would say, it could identify, oh, another demo. It could identify, let me stop it. It could identify him by name. It could also have this CEO's decentralized identifier in there with those capabilities. And so that's how then a regulator could automatically verify all of this, right? So if he has a credential saying this DID has these capabilities, and then he can also sign something proving control of that DID, then that's how they can automate all the way back. But I think I like this demo because it also shows how it can integrate into existing workflows. Like, you don't have to start with everything in verifiable credentials from the start. So, but when you're at that point, you're already leveraging people that you trust, like company officers or people who are doing a function like that anyway. And you would also assume that there are, safety measures in place. If that person makes a mistake, that they can revoke it. If the company officer makes a mistake, things like that.
So applies equally for companies and for individuals.
Yeah.
Very cool. And what's interesting here is, this is a bit squeaky, isn't it?
You want to swap?
Hang on. Yeah, turn yours off as well. Oh, there we go. What's interesting here is the movement towards interoperability. Okay, so we're seeing more and more companies jumping into this space. So Uport were actually going with this stuff before Evening cropped up. But there's a consolidation to DIDs and verifiable credentials as standards now. And that's letting lots and lots of other organizations jump in as well, which is great because it means there's more acceptance. It ceases to become a proprietary thing where, it's like Uport versus Evening. Okay? It's about growing the whole ecosystem, and the more people that come in, the better. Because somebody like IBM coming along, you might think, oh, they're kind of a bit huge. They've got more marketing dollars than anyone else has, well, apart from Microsoft, but they're huge and they're in as well. But that's really good because if Microsoft or IBM Credential enable all the stuff they do, or Salesforce do, or then it means there's going to be a whole world of credentials out there, and there's going to be many, many more people who can accept them, and many more places where you can use them. So that's why this open source stuff is really important. So there's been a number of kind of diversions from standard that are now coming back together based on DIDs and verifiable credentials and all the complex crypto under the skin, which is really good to see. So this, the Glyph one was really good. They actually did a parallel one with Glyph with Sovrin as well. But because they wanted to show to the banks and the regulators, don't worry about which ledger, it's the protocol on top that's the important stuff. So it's a really interesting one, this one. So interesting to see how it goes.
Yeah, in the U.S., the Department of Homeland Security is funding a lot of not grants, but grants effectively to help prove interoperability. So making sure, so some of the scenarios that they're interested in are work. I'm going to get the right terminology. What's that? The ability to work. So we don't have national identity cards, but something like a resident card, something like that. So, but before they really go forward with it, they want to make sure that it's interoperable. And so a lot of companies in the space, one that we haven't talked about much is called Digital Bazaar. They have Verus One networks. They have a similar, I won't say there's a lot of differences, of course, but they have sort of a similar approach as Sovrin in terms of like a fit for purpose blockchain as opposed to something like a proof of work blockchain like Bitcoin or something like that. So yeah, there's a lot of work to proving interoperability, and from a standards perspective, it's nice that so many of the players are we're starting with not a whole lot of massive companies, or rather they're late to the party. So a lot of work has been done by smaller entities that have been working together. And so it makes it much harder for the very large companies to come in and kind of take the standard in a way that would not be in the interest of individuals.
And maybe some of you are thinking, how do you start? How do you get started? So great, there's a bunch of open source stuff. Great, there's some suppliers with some products, but what do you start doing? And there's a couple of easy ways to kick off. The first is issuing credentials to your own staff. Okay, really easy. They're a captive market and they can't say no. And it lets you put a credential exchange platform in place and give people staff IDs, which you can then use for single sign-on to all your company systems. That's really easy to do. You don't need anybody else. The second thing you can do is you can give your own customers credentials they can use to authenticate themselves when they log back in. Or if you've got multiple silos in your organization, you need the customer to go across them. So again, they're your customers. You maybe have an app. We have an app SDK, so all the functionality you saw me demoing on the screen, you can build into your own app. And your customer can then be the courier of the data across the different silos you have and sign in seamlessly, no username and password, but then they have a credential they can use elsewhere as the ecosystem expands. So what we're seeing is there'll be small islands of credentials that are sort of self-contained. So there'll be doctors with doctor IDs in the National Health Service, and there'll be, I don't know, people with bank identities over here, and then suddenly the doctor with his doctor identity will need a bank account, and he'll have all the credentials he already needs to sign up. And the bank customer, who also happens to be a doctor, she'll be able to more easily get her doctor credentials because she's got some bank identity that she used to prove who she is. So these islands of credentials will expand and overlap, and that's because the ecosystem is completely open. So a credential issued here in Switzerland can be consumed in Canada or in Australia or anywhere. So there's no geographic boundaries here, which is what makes it really powerful.
I have a slide that kind of that presents sort of by industry or some example use cases and how it's spreading. So for example, like these are some major players with verifiable credentials, decentralized identifier prototypes, or pilot deployments underway. But obviously education is a big one, and this is not an exhaustive list of companies. There are a lot of or institutions. There are a lot of educational issuers right now of at least precursors to the verifiable credential standard. So the verifiable credential standard, I should clarify, it just passed recommendation. So, I'm using a very strict definition of verifiable credential. Everyone is aware of this standard and kind of working towards it. So yeah, we have financial services. I think some that Andy pointed out earlier, CU Ledger and ATB Financial, are some that have strong pilots. I think the ATB Financial, I think, was sort of a KYC sort of thing. Maybe you know more than me.
Yeah, that was KYC and onboarding. Yeah.
Then we have a lot in trade and logistics, and so actually I should show one thing real fast. I think as I mentioned, Department of Homeland Security, they're very interested in decentralized identifiers and verifiable credentials for supply chain management, combating counterfeit goods. So this is an example of, several things. It might be objects with verifiable credentials. It might be, governance or stewards or sort of delegates of a certain corporation being able to act on behalf of someone else. But so they've come out strongly in favor of this, but they're also, this is the other reason they're funding interoperability efforts, because they can't pick a technology that's going to benefit one vendor. Back to here, so trade and logistics, there's a lot of scenarios there. Insurance, I'm a little less familiar, but yeah, workforce, that's something I'm interested in. I think I've been very focused on the educational side. Workforce, of course, is another critical piece of that. So we're getting a lot of educational institutions interested in issuing. They're aware of the problem. They know the cost and the problems of degree fraud, but it's not that valuable until employers start understanding how to work with it. So not just going to a site and clicking verify and knowing all that. They want it to be integrated with their systems, right? So if they can do bulk verification of applicants, things like that. So a lot of that, those pilots are happening in the U.S., at least in the T3 Innovation Network. So a lot of big employers like Walmart are working with standards bodies, educational institutions to unsilo their formats in their databases and start to work together. So I think that's going to be, once we get a sort of employer, educational institution matchup, that would be a round trip. And then there's ongoing learning that happens in the workplace. Maybe people get additional training. So I think that's going to be a sort of short term, an area where we'll start seeing a lot of progress.
Cool. So the aim of this revised agenda piece was to give you an idea of use cases and show you what it looks like. I'm hoping, are we okay on that so far? Is everyone happy that we've done that? We could sit and talk about use cases for the next 2 hours, but you guys will be able to come up with use cases yourselves, right? We're not use case experts. We don't know every single industry in the world. We don't know how your business processes work, but what we want to do is show you that there's a new capability that allows you to do things in a different way that wasn't possible before. And there's a growing interest in it, and there's some very big names on here. There's people that aren't on here that are huge, that are busy working on this this kind of capability as well. There's various estimates. I think Gartner are saying by 2025, 40% of digital interactions will involve credentials, digital credentials of some sort. It's pretty punchy, it's pretty bullish. But I think there's going to be such competitive advantage in accepting and issuing credentials that to not do so is going to be like not having a website. It'll literally be like that. So it's still quite early days. You guys are in amongst the pioneers. But it's all open. You can come and play, you can participate, you can come up with your own use cases, you can build your own stuff. You don't like ours or Viewports or whoever else is, you can create your own. Build on top of the open source stuff. So really that's what we wanted to get across today. I don't know if we need to cover any more. I'm kind of, are you all PowerPointed out? Would you like some more PowerPoint? So I guess if there's no more questions, we can wrap up. Yeah? Does anyone want to cover any more? No? Or you can speak to us afterwards if you're too shy. Abby? Yeah, I think you spoke to Abby, didn't you?
Yeah.
So Abby knows we've moved the agenda around, doesn't he?
Okay.
Yeah, so I think we're good. Okay, so I think let's wrap up then and say thank you for coming and being an attentive audience, and feel free to attend the other sessions that are still going. Thank you very much.
Thank you.